So an arithmetic series, as opposed to an arithmetic sequence, is the sum of the terms of an arithmetic sequence. And like I was saying in 10.1, instead of having to write out every single term and then add them together, we're going to have a formula. This formula is Gauss's formula, and it comes from the story, which I'm nervous to put this on a video because I'm like, well, is this true or is this a story I made up? But I always say that there was this little guy, Gauss, who was in class one day, and this is way back when, obviously pre-calculators and things, and the teachers were kind of annoyed, and they're like, what can we make the kids do? We're like, that's it. You're going to add the numbers 1 to 100. And so they said to the class, okay, take your numbers 1 to 100. So 1 plus 2 plus 3, and you're going to add them all up until you've added up to 100. I thought, okay, this is going to keep them busy forever because that's a lot of numbers to actually add together. But Gauss put up his hand and said, I know the answer. And he had found it in like 5 seconds. And again, I could be elaborating and totally making the story up, but it's a good story. And the teachers were astounded. And what he did is, instead of actually adding the numbers together, he looked for a pattern. And the pattern became Gauss's formula. And Gauss's formula goes like this. It says Sn, so the sum of any terms, is equal to the number of terms you're summing divided by 2 times the first term plus the nth term. So whatever number of terms that you're adding together. So Gauss said, okay, if I was going to find the sum of 100 terms, so 100 divided by 2, I'm going to find that by taking the first term, which is 1, and adding it to the last term, which is 100. And then I'm going to times that by 100 divided by 2. And what he found is that the answer is 50/50, so 5,050. And so instead of having to add them together, he found this formula that can find the sum of any number of terms in any arithmetic sequence. And the way it works is like this. If you took this sequence and you wrote it backwards, so if I wrote 100 plus 99 plus 98, and then this would be 4 plus 3 plus 2 plus 1. So we just wrote the numbers in reverse. And it doesn't have to be a common difference of 1 for this to work. It's any common difference. Is that if you take the first and the last term, so the 1 plus the 100, and you add them together, you get 101. Well, what happens is that if you add any two terms together from their subsequent places in line, you'll always get 101. So if you add the second number and the 99th number, you're going to get 101. If you add the third number and the 98th number, you're going to get 101. And what happens is that you're always going to get 101. But what we've done is we've got 2 rows of the numbers. Instead of having 100 numbers, we actually have 200 numbers. And so what we have to do is say, okay, well, if I'm going to add the first number to the last number, then I'm going to times that by the number of terms there are divided by 2. And then that works out to finding the sum of any arithmetic series. So this becomes a formula that we can use to find the sum. So for example, if I wanted to find the sum of the first 15 terms of this arithmetic sequence, I know the formula for finding the sum is S sub n, so the sum of n terms is equal to the number of terms divided by 2 times the first term plus the nth term. So if I wanted to find the sum of 15 terms, I would do 15 divided by 2, and I would times that by the first term plus the 15th term. Now in this particular sequence, they didn't give me the 15th term, so I have to use this formula to first find the 15th term. So the 15th term is going to equal the first term plus 15 minus 1, or 14 common differences of 3. So 4 plus 14 times 3, which is 42. So 42 plus 4 is 46. So I'm going to put the 46 in here. And some people, they choose to like kind of Frankenstein formulas together, and they will take this and plug it in here, and then they come up with another formula for sum. but we've chosen, or this textbook's chosen, just to give you the one formula, and if you need to find the 15th term, just do it on the side and then plug it in. So if you plug this into your calculator or you kind of work it through, you'll end up with 375 being the sum of the first 15 terms of that sequence. And so then it comes to the sigma notation. Now, the key thing is you have to know that this is an arithmetic sequence in order to use the formula. So if you want to use this formula, you have to be absolutely positive that this is an arithmetic sequence. So I can tell that it is just kind of the way it's written, but to check, you could always plug in. So if I plug in k is 1, so if I'm finding the first term, k is 1, I get 9. If I find the second term, I get 4 times 2 plus 5, which is 8 plus 5, which is 13. And then to to know for sure, you have to do the third term. So 12 plus 5, which is 17. And then check for that common difference. D is 4, 4, and then D is 4. So since they have a common difference, you know this is an arithmetic sequence or series, which means that I'm allowed to use this formula. So now I have to figure out how to use the formula. Well, the number of terms is always going to equal the top number minus the bottom number plus 1. So this is 130 terms. So there's 130 terms I'm finding the sum of, where the first term we already found was 9. But now I have to find the 130th term. So the 130th term would be 4 times 130 plus 5, which is going to be 525. So I can plug that in, which is a heck of a lot quicker than going the first term plus the second term plus the third term plus the fourth term all the way up to a term 130. You can just now plug it into your calculator and you should get that it is 34,710. All right, pause the video, try the next one. So the first thing I would check is that this is an arithmetic sequence. So I'm starting where it is 5. So I'm going 8 times 5 is 45. Now, 40. Hopefully you can tell that since this is just 8 times each number, that obviously this one is an arithmetic sequence because you're just adding 8 between each one. The next number would be 48. The next number, if I did this right, would be 56. Right, 8 times 7. So I can tell that this is an arithmetic sequence with a common difference of 8. All right, so how do we do it? Well, we're finding the sum of how many terms? Well, n equals 20 minus 5 plus 1. So there are 16 terms in my sequence. So I'm finding the sum of 16 terms, where the first term is 40. And now I have to figure out what the last term is. So I'm going to plug in 20 for k. So I'm going to go 20, which is going to give me 160. So 40 plus 160. So I'm doing 200 times 8, which would be 1600, would be the sum of the first 16 terms in the series. All right, the last part of this is applications. This is applications of arithmetic sequences and series. So we're going to read these questions and you have to decide, is this a sequence question or is this a series question? And then how am I going to use the formula to figure it out? So Gloria accepts a job starting with an hourly wage of $14.25. She is promised a raise of 15 cents. So she's going to increase by 15 cents per hour every 2 months for 5 years. At the end of 5 years, what will her hourly wage be? So after the first 2 months, she's going to be making $14.40. After another 2 months, she's going to be making $14.55. So we know that we can find this using an arithmetic sequence. And the question is am I finding the sum or am I finding a certain term? Well, it says at the end of 5 years, what will her hourly wage be? It's not how much will she have earned, it's what will her hourly wage be. So we're going to be finding a term in an arithmetic sequence. So we're going to be using this formula. Question is, what are we finding? So it says that she is starting with a wage of $14.25. And to that, we are adding a common difference of 15 cents. My question to you is, How many times is she going to get a raise? Well, she's going to get a raise every 2 months for 5 years. So there are 12 months in a year, so she's going to get 6 raises per year for 5 years. So she's going to get 30 raises. And so I know that I'm going to be adding the common difference on 30 times. But if you get really stuck in this formula, you're going to want to put 30 minus 1. But that would be wrong because then you'd only be giving her 29 raises and you want her to be getting 30 raises. And so if you want to do this properly, you're actually finding the 31st term. You're finding her hourly wage, which would be the 31st term if you want to put 31 minus 1. Or I personally ignore the formula and I think of the fact that I want to give her 30 raises. And I don't put n minus 1 in there. I just go straight to putting a 30 in here. So I'm going to give 30 raises of 15 cents per raise onto the 14.25. And that means her hourly wage after the 5 years is going to be $18.75. All right. The next one, a stack of telephone poles has 30 poles in the bottom row, 29 poles in the second row, 28 in the next row, and so on. How many poles are in the stack if there are 5 poles in the top row? How many poles are in the stack all together? We are going to be finding a sum. We're not finding how many are in the top stack, we're saying how many are in the entire stack. So we are going to be using this formula. So what do we know? Well, we know that in the first row there are 30 poles. In the last row there are 5 poles. The question is, how many terms are in this sequence? So there's a couple ways that you could figure this out. The most mathematical would be to say, all right, well, why don't we find the number of terms using this formula? Where I know that in the last row there are 5, in the first row there are 30, and that we have a common difference of minus 1, because in my first it was 30. So if you think of this as a sequence, your first row had 30, 29, 28, and so we have a common difference of negative 1. So figuring this out, I've got negative 25 equals n minus 1 times negative 1. So 25 would equal n minus 1, or there would be 26 rows. And so my number of terms will be 26. So I'm finding the sum of 26 rows where the first row has 30, the last row has 5, and you end up with 455 poles. Therefore, there are 450 poles altogether. Word question, word answer. Therefore, she would earn $18.75 at the end of 5 years. All right. Hopefully you're feeling pretty good with arithmetic sequences and series. Make sure you go and do the homework for 10.2 and then come back and watch the videos for 10.3.